वेरी गुड इवनिंग टू ऑल ऑफ यू। अभी जो आज का जो लेक्चर रहेगा वो जो फोकस होगा वो डाइवर्जेंस पर फोकस होगा कि किसी जो वेक्टर फील्ड का है वो डाइवर्जेंस हाउ वन कैन टेक। बट बिफोर दैट yesterday वी हैड डिस्कस्ड अबाउट टू द gradient and gradient क्या है and how to find out the magnitude, and then after you have seen equation of dv upon dr in terms of del operator, right? So from that uh, we will basically conclude uh, about to the direction, राइट। तो डायरेक्शन क्या है और किस तरीके से हम इसको डिफाइन कर सकते हैं बाय यूजिंग इट। सो हियर इन दिस पर्टिकुलर सेक्शन यू हैव सीन दिस थिंग dv upon dr, and this will be maximum when theta is equal to 0. So theta is the angle in between of this del operator v, that is basically gradient, and this displacement vector. If the angle in between these two is equal to 0, then the rate of change in potential, right, will be maximum. So and that will be obviously is gradient phi, gradient of that particular scalar field. So this was all about to the particular point of gradient potential. Now in this section, first of all let me finish about to the direction. So what is the direction of gradient v? So here we have taken actually the potential, and this can be written as gradient v del operator v. So we have to find out the direction of the gradient v, and this gradient of v you can see here as, so for it we have to assume actually, let suppose let unit vector n in the direction of you can of displacement vector dr. So you have seen here vector dr from this p point to q point. So in the same direction there is a unit vector n, right? So unit vector n and unit vector this dr in the direction of displacement, right? So ये जो है आपका from p to q indicate होगी by the unit vector n, right? Have you got this point? So unit vector n basically is in the direction of displacement vector r, and then by the definition of unit vector you can write here unit vector n is equal to vector dr upon mode of is this vector, that will be dr. So further you can write it or vector dr you can write in terms of the unit vector n and this dr by this way, right? So by this way you had defined the vector dr. Now what you have to do with this vector dr, इसके थ्रू आप क्या कर सकते हैं और क्या इंफॉर्मेशन आपको मिलेगी? तो लास्ट इक्वेशन में आपने देखा कि हमने जो डिफाइन किया था dv अपॉन dr इज इक्वल टू दिस del v and dot r here, right? In this equation dv is equal to del v dot and this dr del v dot vector r. So instead of this vector r, it should be here change into the potential, that will be dr, right? So it will be actually here dr. So now we will take this equation, and this dV change into the potential from point P to point Q will be equal to the del operator V dot this vector dr. So now we have to put this value of dr from this equation, right? So it becomes dV is equal to del operator and this V, that is basically gradient of V, dot dr is equal to unit vector n and simply this dr. Right here, by mistake arrow, there is no arrow here, so unit vector n and dr. So by this way you can write it, and then after a simplification of it, it becomes dV and ये dr यहाँ is equal to del operator and this V dot unit vector n. So by this way you can actually write it. So in this equation here you have seen that this dV upon dr is maximum when theta is equal to 0. So जैसे कि लास्ट ये अभी हम लोगों ने डिस्कस किया था, ये थीटा जो है ये एंगल है इन बिटवीन दिस एंड दिस वन, जो आपका ये ग्रेडियंट ऑफ v है और ये जो आपका मोड ऑफ वेक्टर dr है, इनके बीच का जो है वो एंगल है। और जब ये 0 होगा तब ये dV अपॉन dr जो है वो मैक्सिमम होगा। तो यहाँ एक कंक्लूजन जो है वो आपको दिखाई पड़ रहा होगा कि dV अपॉन dr if that is maximum, it means the angle in between these two that should be equal to 0. So vector has direction. So in conclusion, from this equation you can conclude that the direction of delta V has the same direction. Right? In the unit vector जो n है, only then this will be maximum. So del operator V has the direction along which the rate of change V is maximum. So dV upon dr will be maximum when angle in between of these two will be 0. Right? So you can understand that, and delta V and dot A B cos theta, theta is equal to 0, so you will get the product of these two. So only del operator V, because this is unit vector, so magnitude of it will be equal to 1 and you will get only this del operator and V, magnitude of it. So that is a scalar quantity, right? So gradient basically is a vector whose magnitude is equal to maximum rate of change of V and is directed along the maximum rate of change, right? So maximum rate of change जहाँ हुआ है, तो ग्रेडियंट जो आप डिफाइन कर रहे हैं, आई डोंट नो कि ये पॉइंट अभी आपको क्लियर है या नहीं है, बट द थिंग इज अबाउट टू इट you are basically studying here about to the gradient, and gradient जब आप डिफाइन कर रहे हैं तो उसका रिजल्ट ये राइट हैंड साइड में है, एंड यू आर कंक्लूडिंग इट विद द हेल्प ऑफ इट, ये जो आपने यहाँ लेफ्ट हैंड साइड में लिखा है, और ये क्या है, चेंज इनटू द पोटेंशियल, राइट? तो रेट यू आर सेइंग द रेट ऑफ चेंज कितना है, तो जब ये मैक्सिमम होगा तो वो जो है वो उसकी डायरेक्शन होगी, और ऐसा कब होगा, राइट? तो ऐसा कब होगा, व्हेन थीटा इज इक्वल टू 0, एंगल इन बिटवीन दीज इज इक्वल टू 0, ऐसा तब होगा। दैट मीन्स this vector and this unit vector both are in same direction. So change into the potential, right, into the three-dimensional space, and the unit vector n. I don't know this time I able to explain the thing or not, but I had explained here unit vector n direction is from P to Q, and the rate or you can say the change into the potential, the rate of that, right, towards P to Q, this dV upon dr, right, and this unit vector n, if both are in same direction, then you are defining here the gradient. So this is a little bit or I don't know, I have made it complex, but I don't want to say more thing about to it, otherwise it will create the confusion. So this is a simple definition of the gradient in general. So if you want to define the or you want to see the interpretation of it, so you can take different examples of it, right. So you have seen here delta V dot dr is equal to if suppose that is equal to 0, and this will be 0 only when theta is equal to 90 degrees. So it means here you can see this grade del operator V dot dr, it will be equal to 0 when the angle in between these two will be 90 degree. When theta is 90 degree, then that time this scalar product will be equal to 0, and it means that both del operator V and this dr is at 90 degree. So if suppose this is the P point and this one is the Q point, and you are saying that potential is changing in this direction, right, so this direction will be of del operator V, and this direction actually now if you see there is a small element here, that will be the direction of dr. So angle in between these two is of 90 degree right now. So this is a simple geometrical representation of it. So here at this point I stop it because I have made it a little complex, and I don't think and to discuss more about it, so let me divergence, what is that, into the electrodynamics. So here again we are talking about to the divergence of a vector field, and vector field in the last lecture I had discussed that vector field are here E and B, right. So if I am taking a positive charge, so electric field line will be in outward direction like this, right, and if I am taking a negative charge, basically I have taken the opposite symbol, so I take I'm taking positive with the red signal, and these are electric field lines. So in general we take red color for positive and black color for negative. So these are the electric field line, and the direction will be towards the source. So this is the way of, or you can say nature of the electric field for this negative charge, right. So here electric field is inward, and in case of positive the electric field is outward. So these line basically are moving towards the negative charge. So this is the source and this is the sink, you can say. And now the main point to explain the divergence. So for it, actually here I have defined that we are considering electric field. So this is the field of due to this charge, positive charge, and this field is due to the negative charge. You can say it source also, or you can say it sink. Right, now we will talk about to the open surface. Right, this is the open surface. Open surface means the inner area actually is open, looks like a ring, right? So this space is open, but if suppose this space is filled, then it will be treated as a closed surface, right? So now this field is closed, right? So now this is a closed surface. So what is the meaning of open surface and closed surface? Right, so open surface looks like a ring, and closed surface, as I told you, that filled like it. So the overall this area, right? So here area is same, but this is open. This is looks like a ring. So we consider basically a here ओपन सरफेस के अंदर हम इस पॉजिटिव चार्ज को रखते हैं और इस निगेटिव चार्ज को हम लोग रखते हैं. तो यहाँ हम लोग क्या करेंगे इन फ्यूचर, एक्चुअली इफ़ यू रिमेंबर गोस थ्योरम, तो गोस लॉ के अंदर क्या करते हैं कि एक क्लोज सरफेस वहाँ पे एक्चुअली कंसिडर करते हैं, लेकिन हम यहाँ क्लोज सरफेस कंसिडर नहीं कर रहे हैं, यहाँ ओपन सरफेस हम लोगों ने कंसिडर किया है. तो टोटल जो आउटवर्ड फ्लक्स होगा और यहाँ उसी तरीके से जो इनवर्ड फ्लक्स है उसको हम लोग डिस्कस करेंगे इन दी डाइवर्जेंस, जब हम लोग डाइवर्जेंस को डिस्कस करेंगे. बट बिफोर दैट ये अभी यहाँ ये कंसेप्चुअल पॉइंट आपके साथ में शेयर किया कि ओपन सरफेस क्या है, क्लोज सरफेस क्या है, सोर्स किसको बोलते हैं, सिंक किसको बोलते हैं, इलेक्ट्रिक फील्ड की नेचर क्या है फॉर द पॉजिटिव चार्ज एंड फॉर द नेगेटिव चार्ज, राइट. सो इलेक्ट्रिक फील्ड यहाँ पे वेक्टर फील्ड कंसिडर किया है, तो वी हैव टू फाइंड आउट द डाइवर्जेंस एट दिस पॉइंट फॉर एन एग्जाम्पल. और ऐसे ही एक ओपन सरफेस हम लोग यहाँ पे कंसिडर कर लेंगे इन बिटवीन दीज टू चार्जेज. तो यहाँ पहला ओपन सरफेस, ये सेकंड और ये थर्ड वन, राइट. सो इस तरीके से एट एनी पॉइंट सपोज वी हैव टू फाइंड आउट द डाइवर्जेंस, इस पॉइंट पर डाइवर्जेंस फाइंड आउट करना है. तो ये P1 पॉइंट है, यहाँ P ये जो है P2 पॉइंट है और ये P3 पॉइंट है. तो लाइक दिस वी हैव टू डिफाइन द इलेक्ट्रिक फील्ड एट दीज पॉइंट 3 पॉइंट्स. तो उसको हम कैसे लिखेंगे, डाइवर्जेंस ऑफ इलेक्ट्रिक फील्ड, डाइवर्जेंस ऑफ E कहाँ, एट P1, एट P2, एट P3 कितना होगा. तो ये सपोज किया एक कंसेप्ट है और इस कंसेप्ट के अकॉर्डिंग हमको यहाँ इसको डिफाइन करना है. तो इसको लेट्स सी कि क्या होगा. So as you know that electric field is a function of Cartesian coordinate in 3-dimensional system Ex, Y, Z, and can be written as Exi plus Eyj plus Ezk. This is electric field vector in terms of the electric field component along the X, Y, and Z direction. So when you are saying divergence of E, it means you are writing divergence del operator dot E. Right, mathematical notation of this can be written as like this one. So del operator del upon del Xi plus del upon del Yj plus del upon del Zk. right? And then after this vector E, और वेक्टर E को आप कैसे लिखेंगे, EX I plus EYJ plus EZK. And now the scalar product between first component and this one, I dot I is equal to 1, so you can write here del EX upon del X, then after J to J, right, so J dot J is equal to 1, so this will be del EY upon del Y, plus K dot K is equal to 1, so this will be del EZ upon del Z. So this is the result of divergence of E in mathematical form, right? So here you have seen that divergence of E is the variation of the electric field component along the X direction, and similarly for the Y component along the Y direction, Z component along the Z direction. Remember it, EX, EY and EZ are the electric field component along the X direction, along the Y direction, along the Z direction, right? So you have to make it very clear in the beginning that these are the electric field component E, X, EY and EZ, and you are differentiating EX with respect to X. You are not differentiating X, right? You are differentiating EX. EX is the electric field component, right? EY is the electric field component along the Y direction. EZ is the electric field component along the Z direction, right? Remember it, you are defining EX, EY, EZ that is not related with the Cartesian coordinate system. This is the independent quantity E, electric field, right? Electric field is a function of X, Y, Z, and when we talk about to the electromagnetic wave, then we will include T also. But right now we are not taking T, so we are just talking about to the E is a function of X, Y, Z, right? And here EX, EY, EZ, right, is different from these. So in the next, basically you will see EX is a function of for an example X and T, right? So when you will differentiate it with del Y, what will be the result? This will be equal to 0. So now you can observe here that this concept, is it creating a confusion or is it clear now? So that's why I am saying make it very clear that EX, EY, EZ are the component of this electric field vector E. These are not related with these X, Y and Z, right? Here E is a function of X, Y, Z. So EX is also a function of X, Y, Z. EY, EZ, these may be function of any other two, right? So EX is maybe function of Y and Z, like that. So this thing actually I am saying in the beginning, so you can make it very clear, right? So this is the idea of it, and then after I will del EX upon del Y xt is equal to 0, because EX is function of X, not of Y. So when you will write this equation, EX is function of X and T, right? It is similar to this one, Fx T is equal to 2x square minus X plus 2, like this. So Fxt, Fx actually, right, function like it. So when you will differentiate it with respect to Y, so obviously this del F upon del Y will be equal to 0. So this is the meaning. You will see it in a later stage, but here you can understand my point, that mathematically divergence of E is this one, right? Variation into the electric field component along the x, y and z direction. So that was just a basic idea of the divergence of a vector field, and you have seen here that result is a in terms of the quantity, a numerical value, right? So you are getting a result basically in terms of the magnitude, not direction. So here you had observe only magnitude. Magnitude, that means you are measuring or you are observing, or you want to find out the electric field basically value at a particular point, right? At x, at y, or at z, or at x, y, z, at any point into the right. So suppose you have to measure or you have to find out the electric field at this particular point. So what will you do basically at this point? You will take the divergence of it. Here anywhere, suppose you want to find out the electric field, so then that time you had to take the divergence. So divergence हम क्यों लेते हैं, divergence का क्या पर्पज है, तो उसका मीनिंग तो ये रहा, और मैथमेटिकली कैसे लिखेंगे वो ये रहा. इसमें जो कन्फ्यूजन आएगा आपको फ्यूचर में वो इन पॉइंट को लेकर के आ सकता है, राइट. जैसे कि मैं अभी यहाँ पर क्लियर कर चुका था और यहाँ थोड़ा सा बताने का ट्राई किया कि वो कन्फ्यूजन ना हो आपको, तो वो ये पॉइंट रहे. अब एक छोटा सा पॉइंट यहाँ हम यूज करेंगे लाप्लासियन ऑपरेटर का. तो ये लाप्लासियन ऑपरेटर क्यों, क्योंकि इसकी आपको ज़रूरत होगी. तो लाप्लासियन ऑपरेटर एक्चुअली ये डेल स्क्वायर है, और डेल स्क्वायर कैसे आया है, ये आया है स्केलर प्रोडक्ट्स ऑफ डेल ऑपरेटर के थ्रू, राइट. सो लाप्लासियन ऑपरेटर को आप कैसे लिख सकते हैं, डेल स्क्वायर अपॉन डेल एक्स स्क्वायर प्लस डेल स्क्वायर अपॉन डेल वाई स्क्वायर प्लस डेल स्क्वायर अपॉन डेल जेड स्क्वायर, बिकॉज दिस डेल ऑपरेटर आपने ऑब्जर्व किया था लास्ट स्लाइड में, उसको आप कैसे लिखते हैं, डेल अपॉन डेल एक्स आई प्लस डेल अपॉन डेल वाई जे प्लस डेल अपॉन डेल जेड की. So this was the idea of mathematical idea of the divergence of E. So here in this equation you have seen that the result of divergence of E एक न्यूमेरिकल वैल्यू होगी, और एक वैल्यू जो है वो पॉजिटिव भी हो सकता है, वो निगेटिव भी हो सकता है, और वो जीरो भी हो सकता है. सो नाउ दीज आर थ्री सिचुएशन कि अगर एक आप किसी इलेक्ट्रिक फील्ड का डाइवर्जेंस लेंगे तो वो एक नंबर की फॉर्म में होगा, और एक नंबर जो है वो निगेटिव भी हो सकता है, वो पॉजिटिव भी हो सकता है, और वो जीरो भी हो सकता है. नाउ दिस इज द क्वेश्चन फॉर यू कि इफ सपोज यू वांट टू टेक द डाइवर्जेंस ऑफ इलेक्ट्रिक फील्ड एट दिस पर्टिकुलर पॉइंट, तो वो जो है कैसा होगा, पॉजिटिव होगा, निगेटिव होगा, या जीरो होगा. हियर एट दिस पर्टिकुलर पॉइंट अगर आप डाइवर्जेंस लेंगे तो वो जीरो होगा, या निगेटिव होगा, या पॉजिटिव होगा. तो कैसे पता लगेगा, मतलब क्या, मतलब ये कि इस रिजल्ट से आप क्या कंक्लूड करेंगे, राइट. तो एक तो ये कि पहले रिजल्ट फाइंड आउट करना, एंड देन आफ्टर ये कि वो रिजल्ट जो आएगा उससे आप क्या कंक्लूड करेंगे. फॉर एन एग्जांपल आपके पास में रिजल्ट आया पॉजिटिव व्हेन यू वर टेकिंग द डाइवर्जेंस ऑफ इलेक्ट्रिक फील्ड एट एनी पर्टिकुलर पॉइंट. सो यहाँ से आप क्या कंक्लूड करेंगे. अगर आपके पास में ये सपोज किया निगेटिव आ जाएगा तो फिर क्या कंक्लूड करेंगे, राइट. और अगर ये आपके पास में जीरो आ गया है तो फिर क्या आप कंक्लूड करेंगे. सपोज ऐसे कहीं आपने देखा कि डाइवर्जेंस ऑफ ई इज इक्वल टू जीरो है, तो अब इससे आप क्या कंक्लूड करेंगे, इससे कंक्लूड करेंगे द नेचर ऑफ द इलेक्ट्रिक फील्ड एट दैट पर्टिकुलर पॉइंट, राइट. वो आउटवर्ड है या वो इनवर्ड है, वो सोर्स है या वो सिंक है, क्या है, या वो सोलेनोइडल है. So from these three points actually you conclude that nature of the जो चार्ज है वो सोर्स है या वो सिंक है या फिर वो सोलेनोइडल है. राइट, दैट मीन्स कि जो सोर्स है वो पॉजिटिव है या फिर वो निगेटिव है या वहाँ लाइनें जो हैं वो पैरेलल हैं. सोलेनोइड में कैसा है, वो पैरेलल लाइंस आप एक्चुअली ऑब्जर्व करते हैं. और सोर्स का मतलब क्या है, सोर्स का मतलब ये है कि जो इलेक्ट्रिक फील्ड है वो आउटवर्ड है. आउटवर्ड जब फील्ड होगा तब वहाँ जो डाइवर्जेंस आएगा उस फील्ड का वो पॉजिटिव होगा. और जब आप देखते हैं कि डाइवर्जेंस जो है वो निगेटिव आया है तो वहाँ जो आप देख पाएंगे तो इलेक्ट्रिक फील्ड का जो सोर्स होगा वो निगेटिव चार्ज होगा and it is called basically sink. So divergence of E at any point here that will be negative. So इसका मतलब क्या, इसका मतलब ये कि if I consider a open surface around this positive charge and take the divergence at any point, so that result basically will be positive. And similarly it will be true for the negative charge. If I take at any point, right, the divergence, then the electric field will be negative. But where is it zero? Zero कहाँ पर होगा? So in this picture I had already considered all these three situations. So here you can understand that at this particular point divergence of electric will be zero here at the positive, and at this particular point anywhere it will be negative. But if suppose I take here the divergence of electric field at the center of these two charges, then it is equal to 0. So divergence of E is equal to 0. Can you say the region of it? What is the region of it? Right? Anybody is there who can basically explain it? Why it is equal to 0? The reason of it is that the number of electric field lines which enter through the open surface, right, are equal to the number of electric field line which are coming outside. So the flux basically remain constant inward and outward. Because of that this is equal to 0, right? And this is open surface integral. Remember this thing into the divergence of an electric field of a vector field. Vector field may be electric field like I have considered here positive and negative charge. So in the case of magnetic field you can consider the north pole and south pole. The behavior will be same and you can find out and determine all these things, right? So this is just a idea of the divergence in electricity and magnetism, and then after how we can define all these things. So might be this information will be useful to you to get an idea. And now at this point because I don't think that I have to carry further, so now I have to stop at this particular point. And you can observe here that this is only a simple point and I have taken more than 35 minutes. So so by this way you can imagine that at your end how much it easy and or difficult, right? If you have any question you can ask, or you can comment into the comment box, or I will try to put all these videos on my website which you are looking here at the top, apniphysics.com. So there are some basically courses are available there. You can watch those, and you can share this information with the other friends, and wherever what type of problem basically you face, that is conceptual or numerical or in derivation. So in physics actually what basically happens, there are many things which run simultaneously. For an example, I know about to the some concept, right? Supporting concept, I say always to them, supporting physical concept, I know about to them, but you people are not aware about to those things. So I just put directly, I means here the teachers or the book writer, put them directly, and so that your mind basically is not clear about to those things, so get confused. So this is one of the major problem into the physics. So you have to make clear every point in a systematic way. मिस्टर गुरफान खान, ये मैं अभी इलेक्ट्रिसिटी एंड मैग्नेटिज्म का जो चैप्टर है बीएससी में उसको एक्सप्लेन कर रहा था, उसके कुछ बेसिक स्टार्टिंग पॉइंट तो वो स्टार्ट किया है, और उन्हीं पॉइंट को लेकर के ये सीरीज अभी स्टार्ट होगा। तो धीरे धीरे जितना भी टाइम मुझको मिलता है इवनिंग में, तो वो मैं आपके साथ में शेयर करूँगा। बट इफ़ यू आर इन you have any question or like that, you can ask me without any hesitation, and can share your doubt. If that is in my range, I will discuss with you. So thank you for your time and being with me, and making these 36 35 minutes together. सो ऑल द बेस्ट एंड कीप लर्निंग। और ऐसे ही मिलते हैं फिर कल, और जो भी आपका कोई क्वेश्चन डाउट है तो वो आप कमेंट करके बता सकते हैं। सो थैंक यू एंड गुड नाइट।